Section 8.6, Graphing Translations and Reflections. The first two, translation and reflection, are usually pretty easy to draw, so we'll do them both in one lesson. A translation is when you move a shape in a straight line. Years ago they used to call it slides, and they used to call reflections flips. So I'm going to start with the translation, and I'm going to shift this whole shape over 5 blocks. So if I shift it over 5 blocks, this point right here should go 1, 2, 3, 4, 5. It should end up right here. So let's see what happens. So I'm going to shift 1 block, 2 blocks, 3, 4, 5 blocks to the right. So that is a translation of 5 units right to the right. I could also do a translation of 2 units up. So now, if this one here is my original, this one here is my image. And normally, if you're going to label them, if this one was A, B, and C, this one up top here now would be A prime, like with a little 1 up above it. This one would be B prime, and this one here would be C prime, like that. If I were to shift this one again, it would be A with 2 ticks on it, or a double prime. So we're going to worry about doing this one a little bit later. We're going to move on to reflections. So for reflections, you always have to have a mirrored image. If you notice when you're in the mirror, if you hold up your left hand, it looks like you're really holding up your right hand in your mirror. So in this case here, this line right here is your mirror line, or that's where it's reflected. In this case, it's the y-axis. So all I have to do for this one, if I want to reflect this image, I look at this point here, and it is 1 unit or 1 block away from the mirror line. So in order for it to be opposite, you have to draw it 1 block away from the mirror line, but in the opposite direction. So I'll use a different color to make it a little easier. So this unit here, this here point here is A. This one here would be A prime, or the image of that dot. And this would be B, and this would be B prime, and this would be C, and this would be C prime. That's if this is the original and this is the image. So whenever you're doing it, just look for the line that is your mirror line, and then look at your original, and when you're plotting your points, pick 1 point at a time. So I'm going to pick this point here, B, and I'm going to count how many blocks away it is from the mirror line. So I'll go 1, 2, 3, 4, 5, 6, 7 blocks away to the left. So I'm going to do opposite. I'm going to do 1, 2, 3, 4, 5, 6, 7 blocks away to the right. So when you do that for each point, you can then connect them using your ruler, and you can draw your image. So it's pretty easy to draw any mirror line or any reflection, as long as you remember that point. So if I shift a few of these guys out of the way now, just to have a bit of room. Okay. So let's say I want this one reflected, but no longer in the y-axis. I want it reflected in, and I'll make a great big line so you can see it. I want it reflected in the x-axis, or that is my mirror line. So I'm going to start with my C point. My C point is 1 block away from the mirror line, so I'm going to go 1 block away in the opposite direction for C prime. I'm going to look at B. B is going to be 1, 2, 3, 4, 5, 6, 7 blocks away from the mirror line, so I'll count 7 blocks away. 1, 2, 3, 4, 5, 6, 7. So here's my B prime. And of course, A again is only 1 unit or 1 block away from the mirror line, so I'll go down, which is opposite. I'll go 1 block away from the mirror line, so this is A prime. All I have left to do now is join them with a ruler. So I'll join my B prime to my A prime to my C prime, and there you have a perfectly reflected image. You just got to make sure you're doing the opposite distance away from the mirror line. So here's this translation. If you're asked to shift 6 units right and 2 units down, I have the liberty of being able to actually shift this over, so it's pretty easy for me to do it here. But if I had to do each point at a time, I'm going to start with this one. I'm going to go 6 units right and 2 units down. So 1, 2, 3, 4, 5, 6 to the right and 2 down. Then I'm going to do this point. I'm going to go 6 to the right and 2 down. 1, 2, 3, 4, 5, 6 to the right and 2 down. Then I'll do this one. 6 to the right and 2 down. So 1, 2, 3, 4, 5, 6 to the right and 2 down. And then I'll do this one. 6 to the right and 2 down. And then all I have to do is reconnect my lines again. And I have a perfectly translated image. Okay, not too hard at all. For a reflection one, you got to make up a mirror line. So I could have it on the y-axis if I want this time as well, or I can have it on the x-axis, or if I really want, I could have it on any line that I put. I could put a line here if I'd like. And then just simply, if I'm reflecting it about this here mirror line, I can simply count how much it is away from it. So I can go 1, 2, 3, 4, 5 away from it to the left. So I'm going to go 1, 2, 3, 4, 5 away from the right. And obviously I don't have it enough of a chart to do this. So I'm just going to reflect it on my y-axis to make it pretty easy. Otherwise you need a pretty big chart. So let's do this one. It's 2 away from the mirror line, so I'll go 2 away in the opposite direction. Then it's 3, 4, 5, 6 away, this point is, so I'll go 1, 2, 3, 4, 5, 6, there. And then this one is 1 away, so I'll do 1 away in the opposite direction. And then this one is 1, 2, 3, 4 away, so I'm going to go 1, 2, 3, 4 away in the opposite direction, because it's a mirror line and it's reflected. All I have to do now is connect the lines there, 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 and there, and I will have a perfect reflection. And if you have actual letters there, make sure you label the image A prime and B prime and C prime and so on. So whichever way you reflect it, just go opposite from the mirror line in the opposite direction. And again, you have to have a mirror line to be able to reflect it. Okay, in this case, you see the mirror line is right there like I showed you before. So it's 1 away in this direction, so it should be 1 away in that one. And then you count how many away in this direction for the next one. 1, 2, 3, 4, 5 to the right. So I should go 1, 2, 3, 4, 5 to the left. And then do the exact same thing down here. It's 3 blocks or units to the right. So I'm going to go 3 units to the left for that one. For this last point, it's going to be 1, 2, 3, 4, 5, 6 units to the right. So I should go 1, 2, 3, 4, 5, 6 units to the left. And of course, when I join them using my ruler, play a little connect the dots, I should have it, if I did it right, a perfectly reflected image that should look identical. Okay, the last section here, graphing rotations. This one can be a little tricky. You have to remember a few things about rotations first before you do it. And some common things about rotations, and I'm going to make a lovely looking, there we go, this one should be pretty easy to keep track of. So I'm going to make a lovely looking rectangle, and I'm going to go A, B, C, and D, and join them all, join them all together. So now that I've got them all joined together, you can see that I can rotate or flip my image around whatever way I want. Okay? So a few points about rotation. If I turn it this way, it's rotation to the right, or clockwise, the same direction of a clock. If I turn this way, it is counterclockwise, or the opposite distance of a clock. So this would be rotation counterclockwise. So that tells you which direction. Okay? Now, you might also be told in degrees. For example, you might be told 90 degrees. Now, if I were to take a line and put it here like this. Now, if I were to rotate my line 90 degrees, it would have to be like this. This is 90 degrees. So I'm going to rotate this line 90 degrees. There's 45 degrees, I just moved it, and there's 90 degrees. And which direction am I going? I'm going clockwise. Okay? So when you're rotating this one, I'm going to follow this line right here. So I'm going to follow this one just so I can keep it straight. And I should group it a little bit again just so it can't move on me. Now, if I'm going to rotate him 90 degrees clockwise, well, this line is straight up there now. In order to rotate it 90, this line right here should be facing this direction there. Okay, so it's pretty crude, I know, but it should end up facing that direction. So let's rotate it totally in that direction. And as you can see, now that is a 90-degree turn clockwise. Okay? So you have to know these things in order to be able to rotate them when they're on a coordinate grid and you're going to graph it. So let's take this one here. This yellow one is the original image. Okay? I could take these other pieces and just move them if I want. They're identical. They're just rotated a little bit differently. So I'm going to take my original one right here. Now, if I were to say I'm going to rotate this image about the the origin, okay? When you say about, that means which part you're going to put almost like a nail in, and that's the part you're going to keep still as you're moving it around. So if I say about the axis, a certain part of the axis, you'd put a dot on that certain part. If I were to say on the origin, and in a lot of cases that's what you'll have to do, the very middle, you would rotate it about this one. So which way am I going to go? Well, if I'm going to go clockwise, then if you follow this red line here, if I'm going to go clockwise, I would go this way with my triangle. If I was going counterclockwise, I would go this way. And of course, if I said clockwise 90 degrees, let's follow this one line right here. Okay, I'm going to use the black here to be able to move it. If I go 90 degrees clockwise, this here would be 90 degrees clockwise. This line here would have to get all the way down here. And of course, you can test to make sure it is 90 degrees, but most of the time you can tell. You could just simply use your protractor and see if that's a 90-degree turn. And sure enough, if you can move this line down here, that's a 90-degree turn. And I'll show you which one that is here. Okay? So you take this, you rotate it all the way down till this one side here goes down here, and all of this right here from here to here should be 90 degrees turn clockwise about the origin. Funny enough, a 90 degrees clockwise is also really the same as a 270-degree turn counterclockwise. So if you go the opposite, 270, you will get back to the same as going 90 degrees. Another way to go 90 degrees is counterclockwise. So I could take this exact same original, and this would be a 90 degree if we could get this line here to be form 90 degrees from where it used to be. So I'm going to put him right on there. I've already got the image. So I'm going to put him on there, and that should be a 90-degree turn. Okay. So I could check that with, so this right here should be 90 degrees from here to here, and it should be counterclockwise. So that is a 90-degree rotation counterclockwise about the origin, which is the middle, right here. Okay, the last one to do is a 180 degree. Now, it doesn't matter which direction you go when you rotate something 180 degrees. For example, if I were to take a line right here, and I want to rotate him 180 degrees, that would be the full amount of a protractor. So you go from one side of the protractor to the other. It doesn't matter which way I go. I'm going to go completely, I'll start on this side. I'm going to go this way, clockwise, and I still face that direction. Okay? I can go counterclockwise, which is the other way, okay? And I still end up going and then at the same spot. Okay? You'll always still end up in the same spot. So it doesn't matter if you go clockwise or counterclockwise for 180 degrees. So I'm going to put this one down here. Again, this was my red line shown right here. If I totally rotate him, so I'll do that. I rotate him 180 degrees. It should end up, this red line should be facing this way. And of course, there it is, the red line facing that direction. And that should be a 180 degree turn. About, of course, it's about the origin. Sometimes it's not going to be rotated about the origin, and it's not going to be right on the origin. So in the other case, the origin was a point on your figure. In this case, the origin does not touch any of the points here. So the easiest way to keep track of it and to know what you're doing if you don't have any of the paper to use for tracing paper, I like to draw a line going from the origin straight to one of the points. Okay? Now, if I'm told then to rotate it 90 degrees counterclockwise, I'll just think of this line and I'll rotate it 90 degrees, which is this much. So this much is 90 degrees right here. And of course, this point and all of this will end up rotating with it. So I'm going to rotate it 90 degrees. You know the red line is going to end up this way, facing that direction. So I'll do that. And of course, there is my rotation, 90 degrees counterclockwise. And of course, if I wanted to go in the other direction, I just draw my line going this way. And this would be a 90 degrees counterclockwise. And I just simply draw this point here, and it would kind of look something like that if I were to draw it. Okay? So it's going to be facing kind of in that direction then. If you were doing 180, and I'll move some of these out of the way just to make it not so confusing down here. If I was doing 180 degrees rotation, I would do, there we go, and there we go. Alright, 180 degrees, of course, I follow the line I made, will end up going all the way this way like that. In other words, a straight line you'll end up looking at. And when you do that, this guy here, this red line, will end up, if I have this red line, I rotate it completely 180 degrees, he's going to end up like that. So that is a 180 degree rotation. But remember, it's still connected to this one right here like that. So that's what it'll look like with a 180 degree rotation. Okay? So pick a line to follow, and that way you can see whether or not you've gone 180, 270, or 90 degrees in order to rotate. You can use tracing paper quite often to do the same thing. So in this case, I'm going to take my tracing paper, that's the one I'm moving here now. I'm going to lay it on top of my graph. And of course, you guys can trace it pretty easily. So I'm going to trace that, trace it, and trace it, just like that. And I'm even going to use, I think I'll use a little bit of red here. No, I'll leave it. And then of course I'm going to draw my line going right to here. So now I kind of know where it's anchored. It's anchored right at the origin. So now all you have to do with your tracing paper then, and I need to group all of my tracing paper stuff together. See if this works. I haven't tested this one yet. Maybe I should have. Okay, so when you actually rotate it 180 degrees, you will end up, let me see, yeah, I grouped too much of it. You will end up with this whole thing rotating and facing this direction down here. But it's pretty easy to do with tracing paper as long as you make sure that it rotates for you. Let me see. I can see if I can group a few of these together. Okay. So it's not going to group together for me. Perhaps I should have done it earlier. Okay. But that's how you do it. You simply take your tracing paper, rotate it around, making sure that you never end up with your line connected to this. Your line should always end up, when you rotate your tracing paper, your line should always be connected to your middle or your origin.